The goal of this video is to teach you how to use trigonometric formulas like these to solve questions like this, where we have sine, tan or cosine of some angle and we need to write it as a radical expression. But first, we need to learn how to express angles as fractions or radical fractions. For example, cosine 60 is equal to 1/2. Tan 60 is the square root of 3. And cosine 30 is root 3 over 2. With two different triangles and some trigonometry, we'll discover that we can write the cosine, sine and tans of these angles in a neater and more exact form. And I've written some examples on the screen here. And with a little bit of practice, you'll be able to do this in your head. And just to emphasize again, we'll use the trigonometric formulas that I showed at the start of this video to find, for example, tan of 105 and so on. And tan of 105 degrees can be broken up into tan 45 plus 60. But first, let's draw out an isosceles, an equilateral triangle. The isosceles triangle is basically a square that's been cut in half from one corner to the other. This gives us a right-angled triangle with two angles of 45 degrees. If we set both of these sides to 1, we can use Pythagoras' theorem to get the length of the hypotenuse. And we end up with the square root of 2. Now we can use the SOHCAHTOA acronym to give us the ratios of the sides. So sine 45 is equal to the opposite divided by the hypotenuse, which in this case is 1 over the square root of 2. Cosine 45 is the adjacent divided by the hypotenuse, and again this is 1 over the square root of 2. And tan 45 degrees is equal to the opposite divided by the adjacent, which is 1 over 1, or 1. So what about finding the values for the sines, cosines and tans of the 30 degrees and 60 degrees? For these angles, we need to draw an equilateral triangle. Equilateral triangles have sides of equal length and also angles of equal size. So let's set our side length to be 2 and cut our equilateral triangle down the middle. By doing this, we can create a right-angled triangle with angles of 60 degrees at the bottom here and 30 degrees at the top. And because we cut our triangle in half, the bottom edge now equals 1. The hypotenuse has a length of 2, but what about the remaining side? What is the height of this triangle? Because this is a right-angled triangle, we can once again use Pythagoras' theorem to find the length of side B. And with a little bit of rearranging, we find that b squared is equal to 3, and therefore b is the square root of 3. Now we can finish by using our SOHCAHTOA acronym to find the sine, cosine and tan of 30 and 60 degrees. And remember, sine of any angle is equal to the length of the opposite side divided by the hypotenuse. The cosine is the adjacent divided by the hypotenuse, and the tan is equal to the opposite divided by the adjacent. But by using the trigonometric formulas that we showed at the start, we can add or subtract various combinations of 30, 45 and 60 degrees to get an exact radical expression. So I'll show you one example. Let's say we need to find the value of tan 105 degrees. If we simply use the calculator, we get a value of minus 3.732 and so on. And this decimal keeps on going. But the angle 105 is the sum of 60 and 45. So we can express this in a much neater way. So if we use this trigonometric formula here and replace the variables a and b with 60 and 45, we get this equation here. Now remember, we've already worked out what tan 60 and tan 45 is as a rational expression, so we can include these values here. So tan 60 is root 3, and tan 45 is equal to 1. So our expression becomes root 3 plus 1 divided by 1 minus the square root of 3. Now we don't want square roots at the bottom here, in the denominator. We want to remove this root, and the way that we can do this is by multiplying the numerator and the denominator by the reciprocal of the denominator here. And the reciprocal is simply 1 plus root 3. And all we've done here is reversed the sign and made it a plus. So we multiply the numerator at the top here and the denominator at the bottom together. We end up with 1 plus 3 plus 2 root 3. And we get 2 root 3 because we've got 1 multiplied by root 3 plus 1 multiplied by root 3. And in the denominator, we have 1 minus 3. So our final answer is equal to 4 plus 2 root 3 divided by minus 2. And we can simplify this further by dividing the 4 and the 2 root 3 by minus 2, giving us minus 2 minus root 3. And that's our final answer. And if you plug this value into your calculator, you'll find that it's equal to minus 3.732 and so on.